Hello students. So today we'll discuss qualitative analysis of organic compounds. Qualitative analysis of organic compounds. What exactly mean by this particular word? So in general what happen, organic compound will be available on the earth crust will might have some other elements also. For example, it can have the sulfur, phosphorus, nitrogen, halogen, oxygen, right? So, etc. Some other elements also available. So, we have to find out which element actually present in the organic compound. Further, we need to do the different types of detection methods. Now, we'll see one by one. Just you can see there, this is the some organic compound, right? So, in this particular organic compound, you can see here, in this case, you will be having the oxygen is present here. You can see here oxygen this one, and here chlorine is available along with phosphorus also available. Then we have nitrogen available, right? So here again phosphorus available, again oxygen, right? So this is what actually the organic compound that we can able to see in general. So in that organic compound there are mainly organic compound hydrogen carbon will be available. Mainly carbon hydrogen is a major. Then apart from the carbon and hydrogen, we also have oxygen will be available as well as nitrogen, sulfur, then halogen also available. So now we'll try to see how to detect this oxygen, how to detect the phosphorus, how to detect the chlorine, how to detect the nitrogen as well as oxygen. We'll see one by one method. Up to this clear? Okay. Now, detection of first one, detection of carbon and hydrogen. Detection of carbon and hydrogen. So, what generally will happen in this case? So, simple method you can see step by step. Suppose, let us take organic compound you have taken, right? This organic compound we will be treating with a cupric oxide. Now it will converting into copper solid as well as if any elements are available, there'll be suppose carbon is available now, you will get the carbon dioxide gas will come as form. If it is hydrogen is available, so we'll get the water will come like this. Now let us see detection of carbon. We'll see detection of carbon. How detection of carbon it looks like. Let us take here. We have taken organic compound. Assume that in this carbon is available basis we are going. So we will be having the copper oxide will be giving it to the copper carbon dioxide will produce as well as copper solid. So in this case carbon present in organic compound we got the carbon dioxide. So once if you carefully observe here copper is getting oxidized, reduced. Copper here plus 2, here 0 state. So copper is going as a reduction. Copper is reduction, right? So now if you see the carbon 0 to plus 4, so it become oxidation, right? So by this way we can able to get to know how the detection of carbon we can able to see. Let us see now. So we got the carbon dioxide here. Now this carbon dioxide will confirm some more. Let us say if I pass through this lime water, let us say calcium hydroxide if I pass through this one. So we will get the calcium carbonate as a turbidity we can call this one. Turbidity or can say precipitate. Undissolved substance is called as a precipitate, right? Then along with this water also available. Now again when I pass excess amount of carbon dioxide through this solution, excess amount of carbon dioxide through this solution, what I will get here? So a soluble complex will form calcium HCO3 twice. This will be a soluble complex. That is going to say calcium bicarbonate. Name of this one, calcium bicarbonate. So this will be, we can say this one turns into milky, right? Kind of milky color will be present. So that is a detection of confirms that. So carbon dioxide, first what happen here, white precipitate will form. This become white PPT will form. Then when you are again passing excess, will get a kind of turns into milky color. Suppose if I want to see the detection of hydrogen, how we can able to see. In this case, take the copper oxide plus organic compound having the hydrogen. So what happen now? We'll get here water will come liquid. This water, when we treating with a when we treat with a copper sulfate, when we treat with the copper sulfate, let us take copper sulfate. It is in having the white color, copper plus 2, right? White color. Then add some amount of water. Let us take here 5 moles of water I'm taking. So we'll get the copper sulfate dot 5H2. This will be having the, like I say, blue vitriol. Blue vitriol. So this also having the kind of blue color will be there. That's fine. So this is what confirmed that in the given organic compound hydrogen is present. Now we'll see, we'll flow chart in a diagrammatical way how we can able to see. We can see here, so each and every step detailedly we will try to understand here. Okay. Now look at here, carbon reactions. Carbon reacts with a dry cupric oxide, that is copper oxide, when strongly heated to form carbon dioxide. Whenever strongly heating, so here can take here, we have taken the organic compound, right? In that copper oxide we given, now we started giving the heat. Upon giving heat, so what is forming here? First CO2 will form, gas, then copper become metal will form. Now, this CO2 gas turns lime water milky. This is point is important, guys. This is the question we'll frame on this. So CO2 turns lime water milky, then dissolves in excess to form soluble complex, that is calcium bicarbonate will form. So these are the reaction. Excess amount we are passing here. Here excess carbon dioxide plus lime water. This name of this one will be lime water. Name of this one will be a lime water. This one, lime water. This one. Okay. This is the lime water. Now, next what happens? So what is forming here? A white precipitate is forming here. Now, when it is forming white precipitate, so again excess of amount of carbon dioxide is passing through this solution. A soluble complex is forming. So here the soluble complex will be, it looks like this one. A soluble complex looks like that already we discussed in the previous slide, right? So will be HCO3 twice calcium. This is calcium bicarbonate, the soluble complex. That confirm that there is a carbon is present. Now let us see detection of hydrogen. How we can able to see detection of hydrogen will be like this. So hydrogen reacts with dry cupric oxide, when strongly heated to form water. Again, see here hydrogen that is present in organic compound. When we are eating cupric oxide, it will be giving the water. Now water vapor turns anhydrous copper sulfate to blue vitriol. See here, we have taken organic compound, right? Now in this organic compound, so what we are passing here? Copper, hydrogen, copper, cupric oxide, water form. Then we are adding the copper sulfate, so it will converting into a blue vitriol complex is forming. That confirm that in the given particular complex, hydrogen is present. So this formula will be important. Copper sulfate, anhydrous copper sulfate, 5 moles. It will be blue color. The blue color confirm that there is a given compound hydrogen is available. Is it clear? Now, Next, we'll have the detection of other elements. So carbon hydrogen is completed. Now we'll see the detection of other elements. How we can able to detect kind of nitrogen, phosphorus, sulfur, halogen, those elements. Nitrogen, sulfur, halogen, and phosphorus are present in organic compound or detected by Lezine test. It's very very important. These different elements are detected by the Lezine test. These elements present in the compound are converted into from ionic to covalent form, converting into ionic form. Why we need to convert? What is a reason that we need to convert into covalent into ionic? Right? So we are converting covalent compound, we are converting into ionic form. So ionic form, it is kind of slightly polar will be there and that can be dissolved into the solution. But whereas covalent compounds will not dissolve. So if they are not dissolving, it is not easy to identify the which element is available. So that is the purpose. We have to first convert covalent compound into ionic form. There we require Lezine test. Lezine test what happen? In this case, we will take the sodium metal. We will try to make sodium fusion extract. Let us see here. So here cyanide, sulfide halide of sodium so formed and sodium fusion extracted from the fused mass by boiling it with distilled water. What? So this extract is known as sodium fusion extract. Nothing. I will explain one by one. So when nitrogen and sulfur both are present in the organic compound, so then sodium thiocyanate will form. So before that, we'll see the what exactly mean by sodium fusion extract preparation. Look at here. We'll try to see step by step. So reason of preparing a lesson test is what is that? Sodium fusion extract is to convert the covalent compound into ionic. So for that reason, we require the sodium fusion extract. So first what happen? Take a sodium solid form. Now try to break in a filter paper. Right. So here we have taken this filter paper. Now we are making into small pieces a dry sodium. After making a dry sodium small paper, small pieces, so we are taken in the beaker, right? Now in this tube, we started giving the heat the sodium, right? Hot molten sodium will be forming. It's hot, it's kind of converting into liquid form, molten, high temperature. Then after, add some amount of organic compound. Add some amount of organic compound. So here we are adding the organic compound into this. Try to add organic compound we are adding. Add the organic compound. Upon addition of organic compound, so what is happening? Again, still we are providing the heat for the particular glass tube. So after keeping a red hot, after reaching the temperature, red hot temperature, so now try to dip into the water, right? Plunge into the water. So we plunge into the water, becomes cooling. So plunge into the small dish and you take distilled water. In the distilled water, we need to dip or the red hot copper or what's the red hot tube. Now, after dipping water pen, after dipping water pen, so we have to again take this one, try to boil little bit of high temperature, not much more as in the previous case. After boiling, start take the filter paper, then to the filtration process. After filtering what happen, you will be getting the clear filtering solution that we are calling as a sodium fusion extract. Sodium fusion extract we are getting. So this aroma you have to make it like this. This will be like this. Okay. So step by step will be like this. It will come here. It will be starting from here. So nothing guys. Here step by step I'll write the flow chart here. So what will happen in this case? First, take the sodium solid. Then Make small pieces, make small pieces in a filter paper, in a filter paper. And then third point, so keep into the test tube and heat until it become red hot, until it turns red hot, it turns red hot. Fourth point, what happen? This red hot test tube, this red hot tube, dip into the distilled water, distilled water. Then fifth point, what happen? So take again this one, slightly boil the boil the sodium, right? Then sixth one, filter. Then you get the finally sodium extract, fusion extract. You will getting like this. So this is the step-by-step process of preparation of sodium fusion extract. You know, right? The reason to prepare the sodium fusion extract is to convert the covalent compound into ionic compound, so that easy to identification. Now we'll see what will happen. Suppose assume that in the given organic compound, sodium fusion we have taken, organic compound having the carbon as well as nitrogen is present. So what happen now? You will get the sodium cyanide will come. So now see here, the sodium cyanide will be ionic form now. First one. Now second one, what happen? Take the sodium, treat with the sulfur. Assume that sulfur is present in the given organic compound. Take 2 moles. So we'll get the Na2S will form. So here again Na positive, S minus 2 negative, ionic form. Third one, if halogen is present, let us take sodium. In a given organic compound, halogen is present. So we'll get the NaX, sodium hydride will form. So this become minus positive, ionic form. Assume that they both nitrogen, sulfur, both are present. So sodium fusion extract plus carbon plus nitrogen plus sulfur. Three are elements are present. In this case, what happened? You will get the thiocyanate will come. This one. This become plus. This total become minus. So this is the reason that we need to have sodium fusion extract. Right? Now we'll see one by one detection of nitrogen, phosphorus like this. First one, detection of nitrogen. Detection of nitrogen, first what will happen? The sodium, the sodium fusion, the sodium fusion extract is boiled. The sodium fusion extract will be boiled with the iron 2 positive sulfate and then is acidified with the concentrated sulfuric acid. Concentrated sulfuric acid. The formation of Prussian blue confirms the presence of nitrogen in the given solution. Right now, I'll make the step-by-step process to get a clear idea what will happen. First, see the flow chart of this one, how it look like. See, initially, what will happen in this case? Initially, we'll take sodium cyanide, right? Now we are treating Fe2 plus ferrous sulfide aqueous. So you got this complex we got here. Now the step 2 what happened? Now we are oxidizing the Fe2 plus into Fe3 plus, the second step. This Fe3 plus we are treating with the complex what you got there. So finally you got the first Prussian blue indicating that there is a presence of nitrogen in the given organic compound. First we'll see the step by step process what will happen. So here first step what will happen? Now we'll take the sodium fusion extract. So let us take here. Let me remove this one. Yeah. First step NaCN we have taken. When you treat with the Fe2 plus, that is ferrous sulfate. You are getting the Na4 FeCN6 we are getting. This complex is coming. Then after getting second step, what happened? So we are converting we are converting Fe2 plus into Fe3 plus oxidation. How we are doing oxidation? In presence of concentrated sulfuric acid. Concentrated sulfuric acid we are oxidizing. Why sulfuric acid is a good oxidizing agent? So Fe2 plus converting into Fe3 plus. So third step, what will happen now? Third step becomes, so let us take 4 moles of Fe3 plus 3 moles of FeCN6, then minus 4 charge will have. So this will be giving the Fe4 Fe4 bracket FeCN6 thrice. This is the Prussian blue color will there. Prussian blue color will be there. This complex name is, what is the name of this complex will be? So ferric, ferric 3, ferric 3, hexacyano, hexacyano, ferrate 2, ferrate 2. Guys, this is very most important. This will be question will also frame in coordination complex chapter also. So they'll ask the IUPAC name of this one. IUPAC name this one. Ferric 3 hexacyanoferrate. So here this ferric plus 3 state, this plus 2 state. So what is happening here? Take the sodium fusion, then treat with the carbon nitrogen, you got the Na4 hexacyanodoferrate, ferrate, you got it. Then that in the try to convert the oxidize the ferrous into ferrate, ferric. Ferrous converting into ferric. That ferric again treat with the complex what you frame initially, then you will get the Prussian blue color. By showing the Prussian blue color, confirm that nitrogen present in the given organic compound. So here this is the this. Now we'll see there are few questions will be right. The question is the question is talking about, so we'll try to see the question. Hydrogen does not give Lassane test. Hydrogen does not give Lassane test. Why? See guys, to give the Lassane test, to give the Lassane test, the compound must have the condition I will write here. Condition for Lassane test. Condition for Lassane test. The compound should have nitrogen carbon. Compound should have carbon plus nitrogen. Carbon plus nitrogen. Then only it will exhibit the Lassane test. Suppose let us take here NH4Cl is there, no? So this will not show the Lassane test because in this carbon is not available, right? If I take NH2, 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 NH2. This is hydrogen. Here carbon is not available. So this will also not exhibit the Lassane test. Condition is the given compound carbon must be having with along with the nitrogen. Then only it will exhibit the Lassane test. So here hydrogen doesn't give the Lassane test because it doesn't have the carbon in there. So in the Lassane test, nitrogen is converted to cyanide by combining with the carbon of the compound. But hydrogen doesn't contain the carbon, so cyanide cannot form. That is the reason hydrogen does not give the Lassane test. Another one, diazonium salt also. In the case of diazonium salt, there also nitrogen, carbon nitrogen is not there. Means nitrogen is there, carbon is not there. So that does not give the positive test for Lassane test. right? Generally, diazonium salts are unstable and they lose nitrogen gas and heating. Hence, during the fusion, no sodium cyanide will be formed. So, due to this reason, so there is no positive test for the hydrogen as well as diazonium salt. Now we'll see the detection of sulfur. We'll see. So detection of sulfur, how to see here. So step by step process, we'll try to understand very clearly. So in this case, sodium fusion extract is acidified. Sodium fusion extract will be acidified with acetic acid. With acetic acid and lead acetate is added to heat. A black precipitate of lead sulfide indicate the presence of sulfur. And treating with a sodium fusion extract with a sodium nitroprusside appearance of violet color further indicate the presence of sulfur. Wait, so we'll try to understand in this particular case. We'll try to understand this clearly. Now see here. So test for sulfur. We'll explain one by one. So clearly you can see here. We'll take sodium plus sulfur. We will take, right, sodium plus sulfur, assuming that in organic compound sulfur is available. So you will be getting the, Na2S will come. For stoichiometry, take here 2 moles. Now this Na2S, when you treat with a lead acetate, CH3COO twice, lead acetate, if you treat with this, you will be getting the a black color precipitate is forming. This will be black color. That confirm that sulfur is present in the given organic compound. This is the first case confirmation. Now, second case, what will happen? I'm treating with a sodium extract with them, right? So now what happened? So this sulfide, the Na2S, when you treat with the sodium nitroprusside, right? You can take here Na2 Fe CN5 NO we have taken. This is nitroprusside, sodium nitroprusside. Now, when you treat with this one, so we'll be replacing the this sulfur with the NO. So we'll be getting, so here, again here, let us take this equation better way like this. Na2S you can take, so that we get the clear idea. Na4 FeCN5 NOS. This one complex is coming. This confirm that this will be having the kind of a blue color will be there. Violet or violet color. Purple or violet color will be there. This violet color confirm that there is a sulfur is present in the compound. Yes. Then next what happened? Assume that so both there are both sulfur, nitrogen togetherly available. Sulfur, nitrogen together present. In that case, what happened? Let us take sodium, carbon, nitrogen, and sulfur. So what happened now? Thiocyanate will form. Sodium thiocyanate will become ionic now. Ionic will be formed. Now this one, when we try to react with the ferric ion with the NaCN, NaSCN will be forming as, so FeSCN like this plus 2 will be forming. This will be blood red color. Number of times this question was framed in this blood red color. So blood red color confirm that in that given compound sulfur as well as nitrogen both are present. Now come to the in diagrammatic way how we can able to see. Sodium fusion extract is acidified. Sodium fusion extract with acidified acid acidified with acetic acid and lead acetate added to it. A block precipitate, a block precipitate of lead sulfide will be forming. PBS will form, that is a block precipitate, right? So it is a PBS. That indicate that there is a sulfur is present. And and treating sodium fusion extract with a sodium nitroprusside. Sodium nitroprusside. So what is the formula you will be having? Sodium nitroprusside. So you will be having the CN5. This one. With this, if you treat with the Na2S, again when you treat the Na2S, you will be getting the appearance of violet color complexes forming. That confirm that. So there is a this kind of violet color complexes forming that confirms that there is sulfur, so nitrogen is present. Sorry, sulfur is present. First step what happened? Here we have taken the solution. Now we are adding acetic acid and as well as lead acetate in adding into this one. A black precipitate is found. You can see here. Here black precipitate is found here. This one. That confirm that sulfur is present in that. Again, next what happened? We are taking sodium sulfur. Again, we are treating with the nitroprusside. Nitroprusside, we are treating this one. When we treat with this one, you are getting, you can see here, violet color of is forming here. That confirm that sulfur is present in the given organic compound. Now, in case both sulfur and nitrogen both are available, in case both sulfur and nitrogen are available, we will be getting the sodium thiocyanate is forming. And it will be the blood red color on but no Prussian blue since there is no free cyanide ions are present. So Prussian blue will come when there is a only CN is available. But here what happened? SCN, thiocyanate is present now. So blood red color will be coming. See here, we have taken the organic compound, right? In there, we are adding the fusion extract, right? So we are adding fusion extract. Upon addition, so it is forming the so we are adding again treating with the ferric with a sodium thiocyanate. It is forming the obliterate color confirm that there is a sulfur as well as nitrogen both are present. So that is a confirmation of both togetherly sulfur as well as nitrogen is present. So here you can see this. This is how looks like the complex in test tube. Now, if sodium fusion carried out with excess of sodium and thiocyanate, so what happened? They decomposes to yield cyanide as well as sulfide. How? How they will decompose is? So let us take here equation will be like this. Sodium thiocyanate. So when you treat with the sodium, so what is happening in this case? You will get the sodium cyanide separately decomposes as well as sodium sulfide also separate. So this will be decomposition reaction takes place. If you take excess of sodium, so then this will be happening here. So decomposition will be taking place, excess sodium. These ions give their usual taste again. Again, if you take cyanide alone, it will give the violet color taste with there, right? That will be Prussian blue. But if you take a sulfide, it will give the what is that? Blood red color will give, block precipitate will give. Okay, that is the case. You can see here we have taken the sodium cyanide, we are adding the Fe3 plus, right? And sodium metal excess we are adding. Upon addition of sodium metal excess, then it start decomposing like this. So like this. Now we have detection of halogen. We have detection of halogen. Sodium fusion extract is acidified with the nitric acid first, then treated with a, then treated with a, then treated with a, so then sodium fusion extract is acidified with the nitric acid, then treating with, then treating with the silver nitrate solution. A white precipitate is forming that will be soluble in ammonium hydroxide that indicate that presence of chlorine is available. Presence of chlorine will be available. Now, saying like this, if you take yellow precipitate that is sparingly soluble, that is bromine will be available in ammonium hydroxide. If it is sparingly soluble now, that will be bromine. If it is not dissolved in ammonium hydroxide, that will be iodine. Violet will be there. Will be like kind of lemon yellow will be there. Let us see clearly one by one. One second. We will add one slide here. So here we'll see the test. First, what happened? Sodium fusion extract is acidified with the nitric acid, right? Sodium fusion extract is acidified with the nitric acid, HNO3, right? So then treated with the silver nitrate, right? We are acidifying, we are treating with the nitric acid. Okay, so we acidifying the sodium, the nitric acid, then treating with the silver nitrate. So assume that in the given organic compound, so let us take assume that in a given organic compound, halogen is available. Now, if you would start acidifying this one, concentrated nitric acid, so what will happen? It will forming AgNO3. Sorry, NaX will be forming. Right? This will be forming. Now, second step what happen? Let us take sodium halide. When if you treat with a silver nitrate solution, it will be giving the AgX will be giving plus NaNO3 will be separate solution. Now, here the question will come. Suppose if I take AgX, here X is equal to chlorine, bromine, iodine. 3. Okay. Let us try to understand clearly this one case I'm taking, this another case, right? And this another case. Okay. Now, if X is equal to chlorine, if X is chlorine, right? If X is chlorine, what will happen? Now I'm taking if X is chlorine, right? If X is equal to chlorine, so it will be having like this AgCl precipitate. This will be white in color. PPT will be forming. But dissolve, when you try to dissolve, when you try to dissolve into the complex, so when you try to react with the ammonium hydroxide, so it will be forming a soluble complex, for example, AgNH3 twice positive. Okay. So here this will be soluble complex. Soluble. That confirm that in the given particular silver halide will be chlorine is present. Now if X is equal to bromine is available. So we'll be getting the AgBr will come. This also again precipitate. What's the precipitate here? Yellow precipitate. Yellow PPT. When you treat with the ammonium hydroxide, it will be sparingly soluble. Sparingly soluble. Not completely soluble. That confirm that here bromine is available. Suppose if X is equal to iodine is available. So what happen in this case? Let us take AgI will form. It is also lemon yellow, lemon yellow PPT, lemon yellow precipitate. When you treat with again ammonium hydroxide, it will be insoluble. That confirm that that. So one is iodine, one is bromine, other is chlorine. That's how we have to do the halogen test for this one. Now here you can see step by step all the reactions we have given clearly. Suppose NaCl chlorine, AgN irritating, AgCl precipitate is forming white precipitate. Then AgCl, when you treat with ammonium hydroxide, you're getting a complex that is soluble. That is chlorine. White precipitate is chlorine. White will be chlorine. Right? Yellow precipitate sparingly soluble in ammonium hydroxide indicate the presence of bromine. Bromine. Yellowish. Again, another also yellow that will be lemon yellow iodine. That also precipitate, but is that will be insoluble. That is insoluble into the ammonium hydroxide. So that confirm that iodine. You can see step by step here we given all the diagrams so that you should not worry about any mistakes. So now first acidifying the which one? Sodium fission extract, right? So nitric acid we are adding into the sodium fission extract. So we have acidified. AgX will be found, not AgX. So here we found the acidified, like kind of NaX is found. X can be the halogen. Now that NaX, so wait, I will write also that one. I will try to write each thing. So here what is formed here? Sodium halide will be formed here after acidifying. After forming this one, this when you treat with the sodium halide, if chlorine is present, it will form a white precipitate. If chlorine is present, white precipitate. That is soluble into the ammonium hydroxide. Right? You can see white precipitate of chlorine is here. Yellowish. This will be lemon yellow. We can keep it as lemon yellow. Right? Now, chlorine dissolved. Confirm that chlorine is present. If sparingly soluble, bromine present. If not sparingly soluble, dissolution is not there. That is a confirmation of iodine. Next, so here along with this, nitrogen sulfur also present in the compound. So not only halogens available, no, there is some nitrogen sulfur also present in the compound. How to separate those people? How to separate? So the sodium fusion extract is boiled with a concentrated nitric acid to decompose the sodium cyanide as well as sodium sulfide. So here we are taking sodium cyanide as well as sodium sulfide. We are treating with the concentrated nitric acid. So HCN gas evolved as well as hydrogen sulfide gas also evolved. Very bad smell, H2S smell. So why we have to remove them? If they're available, no, they interfere the conformation test of halogens. For that reason, we need to first separate them. So otherwise, they interfere with the silver nitrate test for halogens. If NaCN, Na2S are not decomposed, then white and block precipitates of AgCN, Ag2S will be formed. Right? So after acidifying, if they are not forming HCN gas, H2S gas, no, instead of showing the yellow white precipitate, they will form the block as well as the white precipitate form. This kind of AgCN white PPT as well as Ag2S block PPT will form. So they interfere. So for that reason, first we have to remove those people. Now, Bilstein test. Bilstein test is very another test for halogenation, halogens. So you can see here. First, what happens? A copper wire is taken, right? Like if you take this kind of copper wire, no, at this end of the copper wire, we have to make it a kind of a spoon, kind of width. We have to make it, right? So after making, so we have to take into the oxidizing flame of Bunsen burner. The heating is continued till it does not show the color. It does not impart the blue color flame. You have to heat until it will be should not impart the blue color. So the red hot end of the copper wire is now touched with the organic compound substance. A sample is and once again kept under the flame. So the appearance of green or blue color indicate the presence of halogen in the organic compound. Now we'll come to the this diagram test. What happened here? See here. So this is the copper wire. You have taken this copper wire. So let me not take this one so that this will be confusion will take place. What I will do now, I will take this red one. Okay. So this is the copper wire. Okay. Now this copper wire, we just make like a kind of flatten, right? We kept on the Bunsen burner flame. We have to heat until no color will be import, right? As you can see here, I use a flat copper wire, heat it in an oxidizing flame until no blue color will be imported. Then reheat the flame. Then what to do now next step? Take the red hot copper wire, then try to touch with the organic substance. This is the organic substance. This is the organic substance. After touching the sample, so this will be sample. Now take this again to the Bunsen burner flame. So now put the wire back into the Bunsen burner flame. No NaCN, Na2S, only halogen is be detected, right? So if halogen is present, no, right? So then it will show the kind of a green color or a blue flame indicate the presence of halogen. If blue green is not coming, so there is halogen is not available. So instead that what available? There will be having the sodium cyanide as well as sodium sulfide is present. Now what is the limitations having this one? The substances such as urea, thiourea do not contain the halogen but give the test. Right? Urea will give the test, but that does not have the halogen. Give the test for this one. Urea, you will be having the carbon is there, nitrogen will be there. Now it does not tell which halogen is present in organic compound. It gives the test, but it doesn't have the clear idea which halogen, chlorina, bromina, iodina. Layer test will be again for test of bromine as well as test of bromine as well as iodine. Only bromine as well as iodine. Test for bromine. So before going to this one, let us try to understand. So one small topic here. What is the topic? It will be like this. Suppose you have taken halogens. Halogens you have taken. Okay. So what we will do? Let us take halogens. Right? Fluorine, chlorine, bromine, iodine. These are the halogens. So halogens having the oxidizing power. Oxidizing power will be so fluorine is more than chlorine, then iodine we have. So why this will be like this? Due to their SRP is positive, higher positive for chlorine, low positive for iodine as compared to in the four elements. So here E naught value SRP is proportional to the oxidizing power. Oxidizing power. That means what happens? It can takes electron from other, take electron from other. So here, one point must be clear. Here, what is the one point here is fluorine can oxidize chlorine, can oxidize chlorine, but reverse is not. But reverse is not true. This one point. Second point, chlorine, chlorine can oxidize below R, can oxidize below all the elements like Br2, Br and iodine, it can able to oxidize. Here, fluorine also, it can oxidize all. Chlorine, bromine, iodine, all it can able to oxidize fluorine. If you see the third point, no, bromine can oxidize, can oxidize, this should be oxidize, no? Oxidize only iodine, not to the any other one, right? As you go down the group, its oxidizing power decreases. As you go down the group, oxidizing power decreases due to their E naught value is decreasing. That is the reason we need to know this one. Now let us take, so both AgBr, AgI are yellow precipitates. Both are yellow precipitates. It is little bit difficult to identify given halogen in a bromine as well as iodine because both are yellow precipitate only. It is bit difficulty to separate them. So then we are using the, to confirm that, chlorine water test we are using. This is called as a chlorine water test. Sodium fusion extract is acidified. This one, sodium fusion extract will be acidified with sulfuric acid or HNO3, right? In the presence of this one, carbon tetrachloride or chloroform, right? Then excess of chlorine water is added. Excess of chlorine water be, let us take here in place of halogen, you can take chlorine. Then start constantly shaking. We have to shake. Suppose I have taken this beaker. In this we have taken the chloroform as well as sulfuric acid and solution of halogen compound is there. So when you start shaking like this, so at some point it start forming the one layer will form. Right? Let us try to see the layer how it will form. See this one, the case of test for chlorine conformation test. Chlorine conformation test we'll see. So here, if chloroform carbon tetrachloride layer becomes yellow or brown, indicate that bromine is present. Yellow or brown, that indicate that mostly Br will be having the brown, reddish brown will be there. So if reddish brown is coming, that confirm that it is a bromine. Br to dissolve in chloroform and carbon tetrachloride give the yellow or brown color. Look at here, step by step. First, acidify the fusion extract with sulfuric acid or nitric acid. Then add some chloroform. Add 1 or 2 ml of chloroform or carbon tetrachloride. After adding, so what will happen? This is the, after adding carbon tetrachloride. So this is the second step, not third step. This is the second step. Add chlorine water. This is the second step. Let me write here. It was wrongly printed. So this is the step 2. This is the step 2. Okay. Now this step 2, what is happening here? Add 1 to 2 ml of chloroform to the particular solution. After adding, you can see here sodium bromide plus Cl2. This is a fusion extract. We are adding chlorine. So what happened now? It will be forming NaCl as well as Br2 gas. This gas is formed like this. You can see here yellow or reddish brown kind of layer test is forming. No? Kind of layer is forming here. That layer confirm that there is a Br is present. What kind of layer here? You can see here excess of chlorine water is added and shake well. After shaking, leave for rest. So then what happen? The organic layer will be forming. Br2 dissolve in the chloroform. Br dissolve in the chloroform or carbon tetrachloride layer giving yellow or brown color. So yellow brown color indicate that there is a presence of bromine. Now confirming the iodine test, same method as it is. You can see here, but here color alone different. Violet color will give sodium iodide solution we taken, chlorine water we are passing, so we got the iodine. How the iodine will come? Look at here again. Same step, acidify. Here again, this will be step 2. Okay, acidify H2SO4 as well as HNO3 acidification, right? After acidifying, so what to do now? Add carbon tetrachloride or chloroform as well as carbon tetrachloride. After adding, so add Cl2 as well as fusion, then it is forming the iodine. See, iodine slightly started forming the violet color. So iodine dissolve into the chloroform or carbon tetrachloride give violet color. So you can see here kind of layer is forming violet color, or it can also give yellow color violet. Right? So violet organic layer is forming that confirm that iodine is present in the given compound. Now detection of phosphorus. Detection of phosphorus what we have. So the compound is heated with the oxidizing agent. Let us say sodium peroxide oxidizing agent. You can see here phosphorus organic compound. When we are treating with the sodium peroxide, so it first forming the sodium phosphate will be forming. The sodium phosphate acidify with the concentrated nitric acid. It is forming the phosphoric acid is forming. This phosphoric acid, when you treat with the so ammonium molybdate, 12 NH4 twice MO4 molybdate, and again add HNO3, that will be giving the ammonium phosphomolybdate. Guys, this is very very important. The color will be canary yellow color will be there. Canary yellow color. That confirms that in the given organic compound phosphorus is present. You can see step by step. The phosphorus present in the compound oxidized to phosphate first. Phosphorus converting into phosphate. Then phosphate treating with the ammonium molybdate. Then giving as a ammonium phosphomolybdate. That color will be canary yellow. See the step by step here again. Step by step. So 1 second guys. So this will be step 3. Okay. Now look at here. Heat the compound with the sodium peroxide. Right? What are you doing now? Sodium peroxide we are taking, treating with the phosphorus. It is forming the first sodium phosphate Na3PO4. The sodium phosphate, again what we are doing? Let me write here again one more time step by step. Sodium peroxide treated with the phosphorus. It will be this organic compound in the phosphorus, assuming Na3PO4 is forming this one. So then this Na3PO4, Na3PO4 acidify with a concentrated nitric acid HNO3. It will be forming as a H3PO4, phosphoric acid is forming H3PO4. Now this H3PO4 or treated with a NH4 twice MOO4, MOO4, it will give you the, so again add HNO3 here, it will give you the, so the molybdate is forming, right? So what kind of molybdate is forming here? So NH3, NH4 thrice, PO4, so 21, 12 Mn, 12 MOO3. This confirm that this, so this will be ammonia phosphomolybdate. This will be having the canary yellow color. That confirm that phosphorus is present. In this step by step clearly I have taken this one. This will be the color of ammonia phosphomolybdate. That indicate that phosphorus is present. Now last one, detection of oxygen. See, there is no direct method of detection of oxygen, right? Generally what we'll do, if organic compound is heated in a dry test tube, their bubbles will form in the open atmosphere. If you try to heat now, walls of the container, walls of the test tube, bubbles will form. The bubbles indicate that oxygen is present. That's all. Thing is there. If water droplets are formed on the walls of the test tube, indicate the presence of oxygen. No other test, right? This is the only test we have to do for this one. Example, presence of oxygen can be known by testing the functional group containing oxygen will be there, COH, CHO, NO2. How to confirm? Suppose if I take like this, no, let us say organic compound having this kind of complex compound is found. Now what to do now? Let us take here NH. If I treat with this, no, what happen? So salt will form. Along with this, you will be getting the hydrogen gases forming. That confirm that there is oxygen is present, it will become acid. Okay. like this. You can see here, heat the organic compound in open atmosphere, like presence of nitrogen. So you can see here, kind of bubbles are forming. These bubbles indicate that oxygen is present in the given organic compound. If water drops forming inside test tube, then presence of oxygen. If not formed, so there is no oxygen is present. So now, so these are the five detection of test: sulfur, phosphorus, oxygen, nitrogen, carbon, hydrogen. Right? Now we'll see. We'll try to practice the questions on this. Right? So all the questions once you practice, no, we'll get a clear idea. So what we have studied till now. Organic compound on heating with a copper oxide produces a gas that turns lime water milky, and a substance that turns anhydrous copper sulfate blue indicate the presence of which one? Both carbon as well as hydrogen. Right? So option will be C is the answer. Question number two. During the estimation of carbon and hydrogen, CuO is used because it undergoing gain of electrons, right? Producing the, so you can see here, supply the oxygen of oxygen for oxidation of carbon as well as hydrogen, right? So option B is the right answer. CO2 is forming, HO2 is forming, no? That is the case. Assertion. Question number three. When organic compound is heated with a copper 2 oxide, that is CuO, okay, and carbon is converted into carbon dioxide. Okay, that is fine. Correct only, right? This will be like this. That is forming carbon dioxide. Fine. Copper 2 oxides acts as an oxidizing agent. Yes, it is plus 2. Here copper converting into 0. Gain of electron, oxidizing agent. So supply oxygen for the oxidation of carbon and hydrogen. So both assertion is correct. Reason is also explaining properly. Question number 4. In Lassine test, organic compound containing nitrogen as well as sulfur on fusion with the sodium gives sodium fusion extract, which unsuitable treatment with forms. What it will form? What will form? In Lassine test, organic compound containing sulfur as well as nitrogen. So it will give you the this one togetherly, sodium thiocyanate. B is the right answer. B is the right answer. Assertion. Okay, question number 5. The primary purpose of fusion of an organic compound with sodium metal Lassine test is. I told no. First, we have to use this one is to convert the covalent compound into ionic. So that is the main reason we have to prepare the sodium fusion extract. Sixth question. In Lassine test, halogen present in an organic compound are detected after converting them into sodium halides. That is correct only, no? So we have to take sodium, organic compound halogen is present. So we'll be forming as a sodium halide. First we have to convert into sodium halide. Then halogens present in organic compounds are covalently bonded. Yes, and cannot be taken directly. That is also true only. For that reason only, we are first converting into sodium halide. So that is assertion, reason both are correct, and reason explaining correct of A. Seventh question. In Lassane test for nitrogen, the appearance of blue color is due to formation of which one? Blue color. This one. FeCN6 thrice. Prussian blue. Ferric hexacyanoferrate. Ferric 3. Where is the option will be having C is the right answer. Which intermediate is first formed when sodium fusion extract containing nitrogen? Which will form? First, you will get the this one. Which intermediate form when sodium first treated with the Fe2 plus. When you do Fe2 plus, you get the this one Na4 plus 2 state will form. Option C is the right answer. Yes. Then after what we'll do? We will treat with the Fe3 plus, right? So FeCN6 minus 4. And this will be forming the This Prussian blue will be forming it. So sorry, not Prussian blue. It will form the, so what will form here? Yeah, Prussian blue will form, right? This will form this complex. Now question number 8, what happened? The role of concentrated sulfuric acid in the nitrogen test is due to oxidize only, no? Fe2 plus converting into Fe3 plus. That is the case. 10th question. Which reagent gives violet color with sodium fusion extract containing sulfur? Tell me. Which test? Violet color. So violet color will be coming where? Ferrichloride, nitroprusside. Yes, nitroprusside test. In lesson test, the formation of black precipitate on treating with a sodium fusion extract with a lead acetate indicate that sulfur Na2S, when you treat with the lead acetate, will be forming the PBS. So option will be B is the right answer. Now 12th question. Assertion Prussian blue color is formed in Lazen test only after acidification with the concentrated sulfuric acid. Correct only, no? Right? First it will form Fe2 plus. So we have to convert into Fe3 plus. So assertion is correct. Reason acidification converts iron 2 and iron 3 for the Prussian blue formation. Yes. So the both are correct statement. So assertion reason is correct and reason also is the correct explanation. Now, an organic compound containing both nitrogen as well as sulfur and sodium fusion does not give Prussian blue color. What it will give? Blood red color. Sodium thiocyanate will form, no? Right? So here does not give Prussian blue color because no free cyanide will be present. Thiocyanate is formed instead of cyanide. This will be the answer for this. Option C is the answer. 14th question. In Lazen test, yellow precipitate insoluble ammonium hydroxide. Yellow test is insoluble. So chlorine will be soluble, bromine sparingly soluble, iodine not dissolved. So that is option C is the right answer. Which of the following silver halide is sparingly soluble in ammonium hydroxide? Sparingly, that is bromine. 16th question. Assertion sodium fusion extract is boiled with a concentrated nitric acid. Okay. Boiled with a concentrated nitric acid before testing the halogens of if nitrogen sulfur is present. Yes, we have to convert them into in this form. No? We have to decompose them. NaCN we have to separate into HCN will go separate, as well as we also have taken Na2S we converted into, so H2S, no. So we have to convert into gases form so that they will not interfere in the reaction. So that is correct only, no. Cyanide and sulfide ions react with silver nitrate, interfere with the detection of halogens. So both are perfectly correct. So option A is the right answer. Before adding the silver nitrate solution, the sodium fusion extract is boiled with the concentrated nitric acid when the nitrogen and sulfur is present. So what the purpose of this one? To decompose them. That is what here is the answer is a no. This is the answer for this question. Option C. 18th question. In the qualitative analysis of organic compound, formation of yellow precipitate with ammonium molybdate after oxidation, the presence of phosphorus, guys. Wherever ammonium molybdate or canary yellow is there, no, that is a phosphorus complex. 19th question. In the test for phosphorus, the role of sodium peroxide is oxidizing only, no? Right? Oxidizing only. To reduce the phosphorus into phosphor, no. Convert phosphate, right? Phosphorus to phosphate. This one equation will be like this. Peroxide you have taken as well as so Na3PO4 is forming. This is the case. So the right answer will be option B is the right answer. Now 20th question. The purpose of using chlorine water in the conformation of bromine and iodine test is, what is the purpose of chlorine? It oxidizes no easily, right? It oxidizes the bromine iodide ion into free ion. So option B is the right answer. 21st question. During chlorine water test, the appearance of a violet color, color in chloroform layer indicate the presence of chlorine, guys. AgCl, AgCl is white color will form. Okay, one second. It is a violet color, right? So if violet color is forming, no, that confirm that iodine. Yellow means bromine. White means chlorine, right? This will be violet. This will be yellow, or we can say here better way, brown, better option. Brown, and this will be kind of, you will be having the yellow or white will be there. Yellow or white will be present. But here we will do only for confirmation of bromine as well as and iodine, not for chlorine. So correct option is violet color is that is iodine. Why chloroform carbon tetrachloride added during the test of the very good question of water test. Why we are adding? So to dissolve and liberate the halogen for color observation. That is the purpose of this one. Not oxidize, not neutralize. To dissolve and to liberate the chlorine particular layer. Okay. So that is the option B is the right answer. Okay. So this is what is the test qualitative analysis only we discussed. Qualitative analysis only till now we discuss. We also discuss the quantitative once this completion. Okay. So thank you guys.